All right. Hi, everybody. So I did not plan on being out today, so I'm really sorry that you're getting this notes as a video. I know you had notes over the notes as a video over the first section, but it just is what it is. I know that our quiz is supposed to be on Thursday of this week. I trust me, if you guys really don't feel ready for this quiz on Thursday, we will definitely bump it back to Friday. I don't want to just say that we're going to bump it back to Friday. But because I may get back and you guys are like, this is a piece of cake. So I am open to bumping it back to Friday. We'll just say that. I got to teach my first period class, so you guys are the only ones getting this as a video note. So, I hope it's all right. I know I've been really bad about checking your guys' homework just because you've been in and out and I've been in and out. So trust me, I will check your homework. I will eventually check your homework. So just keep it, save it, make sure that you have it organized so that when I finally get time to check it, I will. So here's what I'm going to do. I'm just going to show the key here. Just pause when you need to check your answers. Okay, a couple notes about the homework. They're not showing any factor trees when they're simplifying these radicals down. And that's to the point where you should get to, like square root of 50, you should just be jumping to the fact that you know that that's 5 square root of 2 because it's 25 times 2. You should be good enough now that you should be jumping straight to those reduced down radicals. Okay, again, pause where you need to if you want to see any of those answers. 90 radical 2 is an acceptable answer for number 46. It gives you the estimated length, but 90 radical 2 is also good too. All right. Okay, so let's get to the notes then. So this is section 1, 3 square roots, day 2. So this is the harder stuff out of the square root notes. Hopefully it's not too bad. This should be a review from Algebra 1. Again, everything from chapter 1 is going to be a review from Algebra 1, but we're going a little bit more in depth, but it should be. Keyword should. Okay, so first example here, simplify by rationalizing the denominator. Now, rationalizing the denominator, we talked about multiplying and dividing yesterday by simplifying with a product and simplifying with a quotient. Rationalizing the denominator just basically means, well, think about what it says, rationalize. To rationalize is to make something irrational rational. Well, look at the denominator. You see the denominator? Isn't that irrational? Haven't we talked about the square root of a non-perfect square being irrational? So basically, I want to rationalize, make the denominator rational. Rationalize the denominator. Now, how do I do that? Well, the best possible way to rationalize the denominator is to multiply both the numerator and the denominator by the square root in the denominator. Why does that help? Because look at what happens. In the numerator, that's going to give me 3 times the square root of 5 times the square root of 2. In the denominator, that's going to give me the square root of 2 times the square root of 2. Well, in the numerator, that means that that's going to be 3 times the square root of 10, because everybody inside goes together. 5 times 2 is 10. And everybody down below, that's going to be the square root of 2 times the square root of 2, which is just the square root of 4. So notice what happens to the denominator. This is 3 square root of 10 over 2. The denominator becomes rational. Okay. Notice that you cannot simplify down the radical 10 over 2. You cannot simplify that down because radical 10 is inside, 2 is on the outside, so it is not simplifiable there. Simplifiable? I don't know if that's a word. Okay. Cue laughter. All right. Take a look here. Whoa, get out of it. If you wanted to go ahead and try this one, go for it. Pause and try it. Okay, now there's a couple different ways to think about this one. In my opinion, it would be best to try to simplify the denominator first before we start rationalizing. And now here's what I mean. The square root of 8 is 2 radical 2. You could do a quick factor tree, 2 and 4, 2 and 2, buddies, 2 comes out, 2 stays in. But again, you should be getting to the point where you don't need that. Okay. So now, oops, I didn't mean to write equal sign. Now I rationalize. And what do I rationalize with? Well, the square root of 2. Why? Because that's the radical in the denominator. So this turns into the square root of 6 in the numerator because it's 3 times 2 on the inside. And then 2 times the square root of 4. But again, at this point, you should know that that's just going to basically just turn into 2. 2 times 2. I don't know why I wrote my 2's different, but that's okay. Because it'd be 2 times the square root of 4, but the square root of 4 is just 2. So it ends up being 2 times 2 in the denominator. So I have radical 6 over 4. No, you cannot simplify that down if you were wondering. Why? Because the 6 is on the inside, the 4 is on the outside. Inside things can only be simplified, and outside things can only be simplified. Okay. Pause and try to go at this one. Okay. So again, the first thing that I'm going to do is simplify the radical. So I've got a radical 6 in the numerator, and then the denominator radical can be simplified. That turns into, well, that's 25 times 3. So 5 radical 3. Okay, so all in total, radical 6 over 10 radical 3. Now we rationalize with the radical 3. So you multiply by numerator and denominator, both with radical 3. Again, to rationalize means you only multiply by the part that's with the radical. You don't need to multiply the whole 10 radical 3 to both numerator and denominator. So that gives us a radical 18 over 10 times 3, which is radical 18 over 30. Now, can I simplify it down? Yes. Look, up top, radical 18. Radical 18 is 9 times 2, or 3 radical 2 over 30. And now look, 3 over 30. Can't I reduce down that fraction? 3/30ths is 1/10. So it's really just radical 2 over 10. That's my simplified answer. No, you cannot make that radical 1 over 5. You can't do that. That doesn't simplify like that. So there's my answer. And I bet some of you may be thinking, wait a second. We could have simplified down that a little bit easier. Take a look here. If I start out with, I've got radical 6 over 2, radical 75. Notice that in this piece right here, those are both inside the radical. And I've just gotten done saying that you can simplify things inside the radical together. Think about what I've got there. That's radical 6 over radical 75. Aren't those both divisible by 3? Yeah. So that means I can do 6 divided by 3 is radical 2 in the numerator. And in the bottom, 2 times 75 divided by 3 is 25, radical 25. And look at that, how fancy. Because radical 25 is just 5. There's my answer. Always look for shortcuts like that. I know in this problem we were trying to focus on rationalizing the denominator, but in this case, you didn't need to if you really didn't want to. Okay. Let's take a look here. Get a blue pen. All right, now that was talking, so we talked about multiplying, we talked about dividing, we talked about rationalizing, which is another form of dividing. Let's talk about adding and subtracting. A really easy concept here. This is just like this. Notice how we have common terms. It's just 16x, right? Same exact thing is going to happen here. 9 radical 3 plus 7 radical 3 is literally just 16 radical 3. You call that common radical terms. Common radical terms. When you have both have a radical 3. If they don't have common radical terms, then you can't combine them. Just like if I'd said 9x plus a 7y. Those are not common terms. You couldn't combine those. It has to be x's and x's, right? It has to be radical 3's and radical 3's. Okay. Let's take a look here. I've got 6 radical 5 minus radical 20. First instinct might be to seem that these aren't, combinable. Again, combinable, I don't know if that's a real word. It makes it seem like I might not be able to combine these. So, but take a look here. Can't I simplify that down? Isn't radical 20 just 4 times 5? So 2 radical 5. The quick buddy system says, yeah. See that? So really, now we see it. They both have common radical terms. 6 radical 5 minus 2 radical 5 is 4 radical 5. So while some may look like they may not be, combinable, they might just be hiding a little bit. You have to do some reducing before you actually can see if they can combine. Like this one. Pause and try this one, and then play when ready. Okay, like look at radical 80 there. Radical 80 is just 16 times 5. Isn't that 4? Radical 16 is just 4 minus 5 radical 5. Okay, negative 1 radical 5. Or just negative radical 5 if you wanted to. Can I combine those? It looks like you want to. It's really close, but no. Yeah, can't combine them. Now, let's take a look at this one. I would write this one down. I've got another one for you on the next slide, but make sure you write this one down. This is a doozy. I'll tell you right now that there will be one just like this on the last. This will be just like the last problem on the quiz. So you're gonna want to learn how to do these ones. These are rough. Okay, so taking a look at this one, now we know all of the properties of square roots. You kind of have to just put them all together. So I've got 5 radical 8 plus 2 radical 3 over radical 8. Looking at the numerator right off the bat, can I simplify that numerator? Like, think about it this way. Can I take this radical 8 and this radical 3? Can I combine those? No, I can't add these together. I could do some simplifying with the radical 8, but I'm actually going to hold off for a second there. Here's what I would do if I was doing this problem. I mean, and I am. But if I were doing this problem, I would break apart the denominator into the two pieces in the numerator. Because, think about a common denominator. You put things together with a common denominator. You have the same denominators. You put them together and you've got one denominator. You can do that same thing. I'm kind of going to make this an uncommon denominator here. Here, take a look at here. Or I'm uncommoning the denominator. I'm just making up words left and right. Okay, take a look at that. Isn't that just a reduced, a separated part, a separated version of the original problem? Why did I do that? Look at that. I've got radical 8 over radical 8. So this becomes 5 plus 2 radical 3 over radical 8. Okay, so now my first part is completely simplified. I'm now just working with this piece to try to reduce that down. So let's reduce down that radical 8. I've got 5 plus 2 radical 3 over 2 radical 2. And look at that. I'm still reducing. Right? Take a look at that. So this gives me a 5 plus radical 3 over radical 2. Now I can rationalize this. It's not fully simplified yet because there's still a radical in the denominator. Rationalize by multiplying by radical 2 over radical 2. So we get 5 plus, don't lose that 5 plus. 5 plus radical 6 over 2. There's my answer. Okay. Try this one, pause it, try this one, and then see if you can figure it out. Okay, here's the solution. So I'm going to do the exact same method that I did it before. I'm going to take that denominator, give it to both parts in the numerator. Why do I do that? Because, boom. So this means I've got a 3 plus 7 radical 10 over radical 2. Now look at my radicals there. I can now rationalize with radical 2. So this gives me a 3 plus 7 radical 20. Oops, that's a 20 over 2. Okay, now take a look at this. I can reduce down that radical 20, can't I? 3 plus radical 20 is 2 radical 5, right? A quick factor tree of 20 says that it's 2 radical 5. So it's 7 times 2 radical 5 over 2. Or, in other words, 3 plus 14 radical 5 over 2. Not done yet. Can't I take 14 divided by 2? So it's 3 plus 7 radical 5. That's my final solution. Now, hopefully, maybe there's somebody out there that thought it in a different way, saw something different right off the bat. Take a look right here. Take a look right there. And more specific, so taking that step out, just rewriting that step out right here, square root of 2. Take a look at those radicals. Can't I reduce those radicals? Don't I have a 10 and a 2? And since they're both on the inside, I can reduce them. 3 plus 7, and then look, radical 10 over radical 2 That can just be the radical 5. 10 divided by 2 is 5. That gets you there a little bit smoother. Okay, no rationalizing needed there. So again, whatever way you try to do, you're going to see this a lot in algebra where you have to, there's a bunch of different ways different possible ways you could do the problem. Some are slicker than others, some are quicker than others, but they should all get you to the same place. Okay. All right. So yeah, I will see you guys on Wednesday.